Okie doke. So, I think I'm ready to go with the last of my topics, which is polluting emissions and the environmental Kuznets curve hypothesis. Oops. So, where have we got to so far? Non-renewable natural resources don't seem to be a huge policy problem, unless there's market power or market discount rates don't reflect social discount rates, or if we have poorly defined property rights, I also mentioned before. But pollution is clearly a huge policy problem, both local, mainly short-lived pollutants, and global, long-lived pollutants. And the reason is, of course, that the laissez-faire market doesn't price pollution. There is, of course, a vast quantity of research about dealing with pollution at the microeconomic level. But what about understanding the big picture? What is the big picture? And this is where the EKC comes in, right? So what is the big picture? What's the empirical evidence? Well, in lots of cases, if we take individual pollutants in individual countries or even globally for some pollutants, for global pollutants, we can see this pattern of rise and fall. Okay, this is two very clear examples, but there are loads more, right? This isn't sort of cherry picking. And as you can see, the dotted line here is GDP. So we've got very roughly here for sulfur, we've got growth going along with GDP growth in the UK from about 1850 up to 1955, 60-ish. Then policy kicks in to deal with pollution, which it's tightened, of course, successively after that. Pollution collapses. Here we have CFCs. CFCs, as you know, come from aerosol, or used to come from aerosol sprays and fridges. Here we've hardly got any fridges, so we have a sort of composition effect here where more and more people start getting fridges and CFC emissions go up hugely. Then somewhere here we discover what's happening to the ozone layer, and here we finally, or after 10 years or so, we managed to agree internationally to phase out CFCs very rapidly, and sure enough, they disappear. Okay, so that's a couple of examples, but there are lots more. Oh, I meant to put in the counterexample, but I didn't get around to it, which is, of course, carbon dioxide is the classic counterexample, where sure, for some countries we can see significant declines, nothing like this, right? This is log scales, so these are huge declines. This is like factor of 10 decline, very roughly. Not quite that, but whatever. We do have countries with declines in carbon dioxide emissions, but at the global level, and it of course is a global pollutant, emissions are still going up. And the same for methane and so on, other contributors to climate change, global warming, global heating, call it what you like. So the seminal work looking at this was Grossman and Kruger. You should have a look at it. It's basically an empirical paper just pointing out these patterns. But they also have a theoretical discussion, which I might mention in a little while. But on this slide, as you can see, I'm pointing out that we see this pattern over and over again. But when we try to sort of systematize it, it's tricky. For instance, if we compare paths for the same pollutant across different countries, it's hard to find clear patterns. The turning point is not at some particular time, it's not at some particular level of per capita GDP. So there's little evidence for a common inverted U-shaped pathway. Okay, so we see this U shape a lot in different countries for different pollutants, but it still seems to, it's a different view for each case. Okay. Meanwhile, we have the pollution decomposition literature, which shows that the key to the decreases is technique effects rather than composition effects. So it's easy to see that the scale effects should drive up pollution, right? If the economy is increasing in scale, all else equal, pollution will also increase. But why might pollution suddenly decrease? Might it be that consumers change the pattern of what they buy to stuff that is less resource intensive, less pollution intensive? Or is it that producers change their production technologies away from using pollution intensive goods like coal towards producing less pollution intensive goods like gas, or potentially cleaning up end of pipe like in the DICE model? And it's the latter, basically. It's producers cleaning up their act. I don't know if we've got the... No, I'm not showing our workhorse model here, but I could have shown you again the workhorse model, right, to explain the technique effects. Then, in a very important recent paper by Shapiro and Walker, what do well, there's a very important recent paper. They decompose historic changes in polluting emissions into the shares accounted for by changes in environmental regulation, in productivity, and in trade costs. And they show that emissions declines are almost entirely driven by increasing stringency of regulation, although there's some role for productivity growth. So productivity growth, it's like we can produce more good stuff with less pollution, or more good stuff with the same amount of pollution, even without the need for regulation. Okay, but apparently that happens to some extent, but the vast majority of the cleanup is due to regulation. Okay, so the empirics is telling us that there are lots of cases of cleanup, and where we see cleanup, it's driven by regulation pushing firms to cleaner technology. Okay, so that's pretty clear, but to get, so I'm going to collect my thoughts. Okay, so this empirical evidence is great, but to predict the future, we need some more theory, right? We want to really understand what's going on. Okay, so we know that when regulation has been brought in, it has caused declines in pollution, or perhaps rather the other way around. Where we've seen steep declines in pollution, it's often because regulation has been brought in. But will regulation always work? Why is that regulation brought in? Why hasn't it happened already for carbon dioxide? When the regulations, if they ever do, get stiffer for carbon dioxide, will emissions go down? We can't just go inductively and say, oh, this is what's happened in the past, it will also happen in the future. We need a model, right? This is like the Lucas critique, if you like. You could Google a Lucas critique if you want to know what I'm talking about. So we need some theory behind this to better predict the future and better understand what's optimal policy. Okay, so what have the theories been? I think we'll go into that in the next video.